How is it going, ladies and gentlemen? This is the Wolfhound, and it's great to see you here. GLM is an open source, header-only mathematics library for graphics programming in C++. In this video, I'll explain why compiling GLM as a static library is a good idea and show you how to compile it from its source code on Linux. Subscribe to the channel, join the pack, you are always welcome here. Without further ado, let's get started. GLM is a header-only library, which means you can directly include its headers in your project without pre-compiling it. While this simplifies integration, it can increase compile times because the library's code is processed every time a source file includes its headers. Header-only libraries often rely on templates. In many cases, compiling such libraries as static libraries doesn't reduce compile times. This isn't the case for GLM, because its developers explicitly instantiate each GLM type, allowing us to compile it as a static library. Let me show you what I mean. I've already downloaded GLM's source code, so let's navigate to the relevant file. As you can see, all types are explicitly instantiated here. The compiler will generate definitions for these specific type instantiations. For example, let's check the definition of the math struct. Here, T and Q are generic types. When types like float64 and medium P are used as template parameters for T and Q, the compiler generates a new class, filling in T and Q for every function, operator overload, parameter, and variable. In other words, during compilation, the compiler writes the complete class with the provided types. By compiling GLM as a static library, you will benefit from faster compile times, smaller binaries, and more streamlined build process. I've written a batch script to automate this process and make it easier to explain. The script will check for required dependencies one by one. If a dependency is missing, it will install it. Confirm whether the GLM's source code has already been downloaded. If it hasn't, it will download it. Ask which CMake generator you want to use, Ninja or Unix Makefiles. Ask whether you want to compile GLM as a release or debug build. Configure the CMake arguments. I've enabled the necessary options and disabled unnecessary ones, such as examples and tests. Optimize the compilation process. The script detects your computer's maximum thread count and uses too fewer threads for compilation. Start the compilation process. Now let's open a terminal in the same directory as the script and run it. Since all dependencies are already installed on my system, the script didn't prompt me to enter my sudo password to install missing dependencies. If there are any missing dependencies, it will prompt you to enter your sudo password. After checking dependencies, the script would normally download GLM's source code. But since I already downloaded it, the script skipped this step. Now I'll choose Ninja as the CMake generator. I'll compile it as release. Compilation is complete, and the library output directory is here. Next, I'll choose Unix Makefiles as the CMake generator. Let's compile it as debug. Compilation is complete, and the library output directory is here. I'm a software engineer specializing in computer graphics, game development, GPU hardware acceleration, AI inference, and cross-platform C++ development. I look forward to sharing more insights with you. Please like, subscribe, and leave a comment. I'll see you in the next one.